Okay, now you look at this first order differential equation. Okay, so you have this one. So the question is express y in terms of x. That means you want to find y. Of course, you have to integrate afterward. You have to separate the variable, and then here they give you the initial condition. That is, if y equal to 0 when x equal to 0. Okay, why they want to give you this? Okay, afterward we see. Okay, now what we do here, we try to separate the variable. That is dy and dx. We separate them. Okay, so we separate like that, dy here, dx here, and then you see all the y must bring over here, all the x must bring to the right hand side. Okay, so what you will have this, something like this. Okay, now the question is how to integrate this. You cannot factorize. If you can factorize this, then you can use partial fraction, but now you cannot factorize, isn't it? If minus, you can factorize, but this one cannot. So what you do is, remember, when you want to integrate, it's actually arctangent. Okay, this one I ask you to memorize. And then this one is a improper fraction. This is improper fraction. So because this is improper fraction, we have to change it to proper one. So how to change it to proper one? Actually, we can use long division like that. Okay, we can use long division like that. But here I show you straight away how I get it. Okay, actually I'm using long division like this, and then when you integrate the 1, you will get x, and going, then you want to integrate this, you get x. Okay, then when you integrate this, you want to integrate -1, you will get ln, but in front you must have a 1, something like that. And then remember, you must always have plus c. Okay, so this is called the general solution. Okay, this is called the general solution. Okay, because the c we don't know, is a constant, is a number. So now you are given the question, you are given x equal to 0 when y equal to 0, so you just substitute. So when you substitute, arctangent 0 is 0, so you get c is 0, therefore you get the answer is like this. Therefore after that the y will be like this. This is actually called a particular solution. This is not the general solution. Why? Because we don't have c. If we have c, because this number we don't know, then we call it general solution. Particular solution means c is 0. Okay, c is 0 only correct for this particular case. That's why we call it particular solution. And it's only correct for y equal to 0 and x equal to 0. Okay, so this is a particular solution. So they give you the initial condition mean for you to find the particular solution. Okay, that's why you see, find the particular solution of the differential equation given here, cos x, cos y, and so on. And then here you see they give you y equal to pi over 6 when x equal to 0. This one is for you to find the c. Then you get the constant c. That is called the particular solution. So what we do here, we try to separate. First of all, we separate the dy dx, bring the dx over here, and then you look all the y you bring over here, all the x you bring to the other side. So you will get something like this. And then after that, you want to integrate the -1, you differentiate sine, you get cos. So you straight away integrate. But here, cos and cos, you get 1. Then this one, you get sine x, cos x, -1. So you integrate this, you get ln sine y because you differentiate it. Then integrate the x, dx, and then here you have sine x, cos negative. Differentiate cos, you have negative, so you must add a negative like this. So that's why you get something like this. Then you see you have the c. So this is again, this is a general solution. Okay, because the c we haven't found. And then after you substitute the condition here, then this one sine 30 degrees is half. Okay, then this 0, 0, so you get the c is ln half. After that you substitute back your c inside here. Okay, from here here, isn't it? So you substitute your c inside, then after that you simplify. You can put the x over here, all the ln you bring together, then you have this. After that you will get this. So this is called a particular solution. Okay, so with this you are able to do question number 1. You see I write here question number 1 to number 7, then 20, 21, 22, 23, 25, 28, and then 30 and 33. So you can try all these questions. Okay, any question you can ask me.